Welcome to Science Excellence. In this video, we will do practice paper B from MadasMaths practice paper series for year 13 students. So let's get started. Okay, the question number 1 is, if x is in radians and a derivative of sine x equals to cos x, prove the validity of above result from the first principle. So you may assume that if h is small and measured in radians, then as h tends to 0, cos of h minus 1 over h tends to 0 and sine of h over h tends to 1. So we can use these two results in our proof. So derivative by first principle. So we have the formula for the derivative by first principle, which is f prime of x equals to limit h tends to 0 f of x plus h minus f of x divided by h, and this formula is given in your exam formula booklet. Okay, so since we have to prove that derivative of sine x equals to cos x, so let's say if you suppose this f of x, then the derivative of f of x is f prime of x, and we have to show that f prime of x equals to cos x. Okay, so let's say f of x equals to sine x. So in the formula we need the value of f of x plus h as well. So if f of x equals to sine x, then f of x plus h will be sine of x plus h. Now we can sub these two values into the formula, and the formula will be f prime of x equals to limit h tends to 0 sine of x plus h minus sine of x over h. Now we can apply the trigonometric identity on this sine of x plus h, and the formula will be sine of a plus b equals to sine of a cos b plus cos a sine b. So if you apply this formula over here, we will get f prime of x equals to limit h tends to 0 sine of x cos h plus cos of x sine h, and minus sine x as it is from the formula above, whole divided by h. Okay, now if you consider these two terms together, the values of sine x, this value and this value, if you consider these two values together and take sine x as a factor out, we will left with cos of h minus 1 and keep the rest as it is, which is cos x sine h whole divided by h. Okay, on the next step, if you split the LCM, which is limit h tends to 0 cos of h minus 1 times sine x whole divided by h plus cos of x sine h whole divided by h. So if you split the LCM like that, you'll get this expression, and we should put the bracket on now because we split the LCM. Now after, if you apply the limits on the values of h, you can take sine x out because we just need to apply the limits on the values of h. You can take this as a outside from the limit, and we can take this value outside the limit. So we will have sine of x limit h tends to 0 cos of h minus 1 over h plus cos x we can take out, and the limit h tends to 0 sine of h over h. Okay, now from the results above available in the question, you can see when h tends to 0, cos of h minus 1 over h tends to 0, and sine of h over h tends to 1. So what we can do then, this result will be 0, so we will have sine of x times 0 plus cos of x times 1 from here. So finally f prime of x will be cos x as required. Okay, so the next question is a sequence of numbers u1, u2, u3, u4 is defined by un equals to 1 over 1 minus un minus 1, u1 equals to 2. Determine the value of the summation n equals to 1 to 20 un. Okay, so for the first we should find some values of u, and then we can check the symmetry of this sequence, and then we can find the sum. So u1 is already given, u1 is 2. If you put n equals to 2 in this sequence, then it will be u2 equals to 1 over 1 minus u and minus 1. So 2 minus 1 is 1, so it will be 1 over 1 minus u1. So the value of this will be 1 over 1 minus the value of u1 is 2, so 1 over 1 minus 2, and 1 over 1 minus 2 will be minus 1, so it's minus 1. When you put n equals to 3 in it, it will be u3 over 1 minus u2, and it will be 1 over 1 minus the value of u2 is minus 1, so you can sub minus 1 over here. It will be 1 over 1 minus minus plus, so it's 1 over 2 half. When you put n equals to 4, it will be u4, which is 1 over 1 minus u3, so it's 1 over 1 minus value of u3 is half, so 1 minus half is half, so 1 over half will be 2. And if you do n equals to 5 in the sequence, it will be u5, which is equals to 1 over 1 minus u4, and the value of u4 is 2, so it will be 1 over 1 minus 2, and 1 minus 2 is minus 1, so it will be minus 1 again. When you put n equals to 6, it will be u6, which is 1 over 1 minus u6, 1 over 1 minus u5, so value of u5 is minus 1, so 1 minus times minus 1, it will be 1 plus 1 over 2, 1 over 2. Okay, so you can see now u1 is 2, u2 is minus 1, and u3 is half, and u4 is 2, u5 is minus 1, and u6 is half. So you can see the symmetry is 2 minus 1 half, then again 2 minus 1 and half, so it's a periodic sequence, so we can write the values in that way. Okay, so we know that u1 is 2, and u2 is minus 1, and u3 is half, so it's u1, u2, u3. So if you check the value of u4 again is 2, so u4 is 2, u5 is minus 1, 3, u5 is minus 1, and u6 is half again. So the next term u7 should be 2 if you follow the symmetry. u8 is minus 1, u9 is half. Then u10 is 2, u11 is minus 1, u12 is half. u13 should be 2, u14 is minus 1, u15 is half. u16 is 2, u17 is minus 1, and u18 is half. Then u19 is 2, u20 is minus 1, and that's it, because we need the sum of the first 20 values terms of the sequence. Okay, so if you add these first 3 terms, the sum of these 3 terms should be 2 minus 1 is 1, and 1 plus half is 1.5. So again the sum of these 3 will be 1.5, 1.5, 1.5, 1.5, 1.5. But over here we have only 2 terms, so it's the u19 is 2 and u20 is minus 1, so 2 minus 1 is 1. So you have 1, 2, 3, 4, 5 and 6. 6 times 1.5 plus 1 will be the sum, n equals to 1 to 20 un. Okay, so if you do 6 times 1.5 plus 1, it will be 10. So that is the sum of first 20 terms. Okay, so the question number 3 is the point P with coordinates 2 over 5 and minus 3 over 2 lies on the curve with C with parametric equations. X equals to 1 over t plus a, y equals to 1 over t minus a, t belongs to R, and t is not equals to plus minus a, where a is a non-zero constant, and we have to show that the gradient at P is this number 25 over 9. Okay, first if we can find the value of a and t by using this point in the parametric equation. So since P is 2 over 5 minus 2 over 3 and x is 1 over t plus a and y is 1 over t minus a. Okay, if this is a point P, so the x coordinate is 2 over 5 and the y coordinate is minus 2 over 3. So if you replace x over here with 2 over 5, so 2 over 5 equals to 1 over t plus a, and y will be minus 2 over 3 equals to 1 over t minus a. Okay, so if you flip the fractions on both sides, apply the reciprocal on both sides, then it will be 5 over 2 equals to t plus a, and minus 3 over 2 equals to t minus a. Okay, so if you add both the equations, then we should add the left hand side with left hand side, this plus this, and it will be 5 over 2 minus 3 over 2, and then we have to add the right hand side with the right hand side. It will be t plus a plus t minus a. So on the left hand side we will have 5 minus 3 over 2, which is 2 over 2, and t plus a plus t minus a, so a minus a cancels out, you left with 2t, and 2 over 2 is 1, and it will be 1 equals to 2t, and in result t will be half. Now we can put this value of t into one of the equation. Let's say if you put in this equation the value of t, then it will be 5 over 2 equals to the value of t is half plus a, and if you take your half to the left, then it will be 5 over 2 minus half equals to a. Then since the denominator is same, so 5 minus 1 is 4, 4 over 2 equals to a, and 4 divided by 2 is 2, so the value of a is 2. Okay, now we know that the gradient of the curve is actually the first derivative, dy over dx. So since we need to work out the derivative by using the parametric equation, and the t is the third variable in the parametric equations, we should use the chain rule in our derivative. So it will be dy dx. So if you times by dt, dy by dt, we'll get the desired chain rule. So dy, now we need to find the dy over dt. Since we have y equals to 1 over t minus a, 1 over t minus a, and y can be written as t minus a to the power minus 1 if you take this up to the numerator. Now if you apply the derivative, dy over dt will be minus 1 at the front, take away 1 from the power by using power rule, and if you simplify this, take this down again in the denominator, so it will be minus 1 over t minus a whole power 2. This is our dy over dt. Okay, now let's find dx over dt. Since x is in the question, x is 1 over t plus a, and it can be written as t plus a to the power minus 1, and if you differentiate this with respect to t, it will be minus 1 again, take away 1 from the power minus 2, and again if you bring this down to the denominator, it will be minus 1 t plus a to the power 2. Okay, so since we need the value of dt over dx in the formula, so but this value is dx over dt, so if you flip on both sides, flip the fraction, so dt over dx will be minus t plus a whole power 2. Now we can sub these two values into the formula above over here. So dy over dt, this one, is minus 1 over t minus a to the power 2, and dt over dx is minus times t plus a to the power 2. Then minus minus positive, the whole thing will be t plus a over t minus a whole power 2, because you have the same powers 2 and 2, so you can write in combined power. So finally we have dy over dx, which is t plus a over t minus a whole power 2. And since we already work out the value of a and the value of t is half and a is 2, so we can sub the value of t and we can put the value of t and a. T is half and a is 2, over half minus 2 whole power 2. So half plus 2 will be 5 over 2, and half minus 2 will be minus 3 over 2. So if you apply the scale on it, it will be 25 over 4 over 9 over 4. So it is 25 over 4 divided by 9 over 4, and if you apply the chain and flip rule, it will be 25 over 4 times 4 over 9, and 4 and 4 cancels out, you're left with 25 over 9 as required. So we have to show that actually the gradient of the curve at the point P is 25 over 9, and we got the result. Okay, so the question number 4 is, the points A, B, C and D are form the parallelogram ABCD, where the above coordinates are measured relative to a fixed origin. So it means this point is from the origin, so its a position vector of this point is OA, which is equals to 1, 1 and 2, and OB is a position vector 2, 1 and 5, and OC is a position vector 4, 0 and 1. Okay, so we have to find, for the part A, we have to find the coordinates of D. So okay, so if you figure out this situation, then let's say this point is O, which is the origin. So from the origin we should have the point D. Let's say this point is D. We have point A, the point B, and the point C, and they form a parallelogram. From the origin O. Okay, so we have to find the coordinates of the point D. So if you work out the position vector OD, so you will get the coordinates of D. So we need to work out OD, and this vector is OA, and if we consider the vector AD, we'll get the vector OD by the triangle of addition, because this is the tail of the vector, this is the initial point of the vector, and this is the terminal point of the vector. So you have to go this path and then from here to here to get OD. So then OD will be OA plus AD. Okay, so if we consider the points over here, the coordinates of A are 1, 1 and 2, the coordinates of B are 2, 1 and 5, and the coordinates of the C are 4, 0 and 1, but the coordinates of D are not given to work out, let's say x, y, z. So this vector OA is 1, 1 and 2, but AD is, we can't define AD because D is not known. We have to work out the coordinates of the D. So but the good thing is AD is parallel to BC, so we can replace our AD with BC. So you can replace this vector AD with BC because they are parallel, and the BC we can write as OC minus OB, difference of the position vectors. So 1, 1, 2 as it is, plus BC can be written as OC minus OB. So it will be 1, 1, 2 plus vector position vector OC is 4, 0, 1 minus OB is 2, 1 and 5. Okay, now if you work out these vectors, then you need to add the x coordinates together. So 1, 4 and minus 2. So 1 plus 4 is 5, 5 minus 2 is 3, so the x coordinate is 3, and if you add y coordinates 1, 0 and 1 minus 1, because you have the negative outside, so it will be 0, and if you add the z coordinates, which is 2, 1 and minus 5, so 2 plus 1 is 3, 3 minus 5 is minus 2, so it is minus 2. So we got the position vector OD, which implies D has the coordinates 3, 0 and minus 2. Okay, so the next part is the points E, B, D are the collinear, so that B is the midpoint of ED. Determine the coordinates of E. So we have to consider the point E. Okay, let's say the point E is somewhere here, and if you connect these points E, B and D, because these are collinear on the same line, and B is a midpoint, we have to find the coordinates of E as the x1, y1 and z1. Okay, so we already work out now the coordinates of t, which are 3, 0 and -2, and b is the midpoint of these 2 points. Okay, so if you consider the coordinates of t and b over here, so t has the coordinates 3, 0 and -2, and b, which is a midpoint of b, has the coordinates 2, 1 and 5, and we need to work out the coordinates of E. Okay, since B is the midpoint between E and D, and we can see from here, if you take away 1 from 2, if you take away 1 from 3, you will get 2. So we need to take away 1 more to get the coordinate of E, which is 2 minus 1 is 1. So this is 0, but the coordinate of the y coordinate of t is 0, but over here the y coordinate of p is 1, so we need to add 1 to 0 to get 1, so we need to add 1 more to get the coordinate of E, which is 2. And the y coordinate of t is -2, but the y coordinate of p is 5, so we need to add 7 to -2 to get the y coordinate of p, and we need to add 7 more to get the y coordinate of E, which is 12. So that means E has the coordinates 1, 2 and 12. Okay, now the next part is the point F is such so that ABEF is also a parallelogram, and you need to find the coordinates of F. So if you consider this diagram again, and we have to plot the point F, and to get the parallelogram ABEF, and then you can find the coordinates of F. Okay, so let's say F is the point somewhere here, and if you connect these 2 points with F to get the parallelogram ABEF, so we need to find the coordinates of F now, which is like x2, y2 and z2. Now since it is a parallelogram, so it means this length should be same as this length, and we already figure out the coordinates of E from the point B. And if you see this, when you move from B to point E, we add -1 to the x coordinate, we add 1 to the y coordinate, and we add 7 to the z coordinate of B to get the coordinates of E. So we have to do the same to the coordinates of A over here to get the coordinates of F. So to the x coordinate of A, from the x coordinate of A, if you need the x coordinate of F, we need to add -1. If you want to work out the y coordinate of F from the y coordinate of A, we need to add 1. And if you want to work out the x coordinate or z coordinate of F from the z coordinate of A, we need to add 7, because the lengths are equal, and we did the same thing to get the x coordinate of E from the x coordinate of P, y and z. So we have to do the same thing over here, because the distance is same and it is given that it's a parallelogram. So since the coordinates of A are 1, 1 and 2, and we need the coordinates of F, so we need to take away 1 from it, so the x coordinate of F will be 0. Then we need to add 1, it will be 2. We need to add 7, it will be 9. So the F has the coordinates 0, 2 and 9. Okay, so the next part is, so the part D is show that the part D is show that B is the midpoint of FC. So we have to show that this point B is the midpoint of F and C. Now we have the coordinates of F and we already have the coordinates of C. So if we have to show that B is the midpoint, so if you apply the midpoint formula on F and C, and if it is same as the coordinates of B, that means B is the midpoint. So let's apply the midpoint formula on FC. So the midpoint formula on FC should be so the x coordinate of F is 0 plus the x coordinate of C is 4 divided by 2. Add the y coordinates, which is 2 and 0, 2 plus 0 over 2. Add the y coordinates, which is 9 and 1, so 9 plus 1 over 2. So it will be 0 plus 4 is 2, 0 plus 4 over 2 is 2, 2 plus 0 is 2 divided by 2 is 1, and 9 plus 2 1 is 10 over 2 is 5, and it is same as the coordinates of B, so that means B is the midpoint of FC. So the next part is prove that ADBF is an other parallelogram. So we have to show that ADBF, AD, B and F is another parallelogram like this one, this one, these lengths. So we have to show that this one is another parallelogram. So if you can prove this length is same as this and this one is same as this, and these are already parallel, so if you can prove that these are equal as well, so you can say this is a parallel. Okay, so let's work out AD from here, AD and FB to check either. Okay, let's work out AD. So if you want to work out the vector AD, it should be the position vector OD minus OA, and OD has the coordinates 3, 0 and minus 2, minus OA is 1, 1 and 2. So if you take away these two vectors, then it is 3 minus 1 is 2, 0 minus 1 is minus 1, minus 2 is minus 4. So this is our AD. Now let's work out FB, this one, FB. So FB will be OB minus OF. So OB is 2, 1 and 5 minus OF is the position vector F, so which has the coordinates 0, 2 and 9. So we already worked out OF from the previous part, it was 0, 2 and 9. So if you take away these two vectors, so 2 minus 0 is 2, 1 minus 2 is minus 1, and 5 minus 9 is minus 4. So it is FB, which is 2 minus 1 and minus 4. So you can see AD is same as FB. Now we need to check the other two, like either FA is equals to DB or not. So let's work out FA now. So FA will be OA minus OF, and OA is position vector A has the coordinates 1, 1, 2, 1, 1, 2 minus OF, and OF is 0, 2 and 9. So if you take away these two coordinates, these two vectors, 1 minus 0 is 1, 1 minus 2 is minus 1, and 2 minus 9 is minus 7. So these are the coordinates of FA. Now let's work out this BD. So BD will be OD minus OB. So the position vector OD is this one, 3, 0 and minus 2. Minus OB is 2, 1 and 5. Okay, so it will be 3 minus 2 is 1, 0 minus 1 is minus 1, and minus 2 minus 5 is minus 7. So you can see this PD is same as FA. So hence FBDA is a parallelogram. So we can say the opposite sides are parallel and equal. So this implies ADBF is parallelogram. Okay, so the next question number 5 is a curve C has implicit equation, and we need to show clearly that dy over dx equals to this expression, which is a constant to be found. So let's do the part A. So before differentiating this implicit function equation, we should simplify this, then it's easy to differentiate. So we have x plus 2y whole square over 4x minus y plus y equals to 3x plus 2, and if we times by 4x minus y throughout to each and every term, and it will be plus y times 4x minus y equals to 4x minus y times 3x plus 2. Yeah. Now if you simplify this term will cancel out with this one, and we're left with x plus 2y square plus, if you take y inside, it will be 4xy minus y power 2 equals to, if you do the term by term multiplication over here, so 4 times 3 is 12 x square plus 4 times 2 is 8x minus 3xy minus 2y. So if you expand this whole square, we can consider this twice and do the term by term multiplication. Otherwise you can apply the binomial to get this x square plus 4y square plus 4xy, the expansion of this square, plus 4xy as it is, minus y square equals to 12x square plus 8x minus 3xy minus 2. So on the left hand side we have x square plus 4y square minus y square will be 3y square, 4xy plus 4xy is 8xy equals to 12x square plus 8x minus 3xy minus 2y. Okay, now if you take this expression from left hand side to the right hand side, so it will be, so the first 12x square as it is, If you take this x square to the right, it's minus x square, plus if you take this 3y square to the right, it's minus 3y square, and plus 8x from this side as it is, minus 3xy as it is, minus 2y as it is, and we already took this x square to the right is minus x square, and 3y square to the right is minus 3y square, and if you take this to the right, it will be minus 8xy equals to 0. So 12x square minus x square is 11x square. 3y square is only the term, so minus 3y square as it is. 8x is only the term, so plus 8x. Minus 3xy and minus 8xy will be minus 11xy minus 2y equals to 0. Okay, so if you now differentiate this equation, it will be take 2 at the front, so 11 times 2 is 22, take away 1 from the power is x, and the derivative of x without power is 1, so there is no need to consider. Minus 3 times 2 is 6, take away 1 from the power is y, and the without power derivative is dy by dx, which is not 1, so we should consider. Plus 8 as it is, and derivative of x is 1, so 8, minus, over here we need to apply the product rule, so it will be minus 11 times x as it is, derivative of y is dy over dx, plus derivative of x is 1 and y as it is, so y as it is, derivative of x is 1. So this is the product rule, which means if this is the first function, x is first function and y is second, so derivative of first as it is derivative of second, plus second as it is derivative of first, so minus t derivative of y is dy over dx equals to 0. Okay, now so we will have 22x minus 6y dy over dx plus 8 minus 11. If you take minus 11 inside the bracket, it will be minus 11x dy over dx, then minus 11y minus 2 dy over dx equals to 0. Okay, now we have to make dy over dx as a subject, so we should take the value of dy over dx on one side and the rest of values should be on the other side. So keep 22x on the left, plus 8 on the left, and minus 11y on the left hand side, and if you take this minus 6y dy dx on the right, so it will be positive 6y dy over dx. If you take this term to the right, it will be positive 11x dy over dx, and if you take this term to the right, it will be positive 2 dy over dx. Now on the right hand side, we can take dy over dx as a factor out, so dy over dx times 6y plus 11x plus 2, and the left hand side is 22x plus 8 minus 11y. So this factor you can take to the left, so it will be 22x plus 8 minus 11y over 6y plus 11x plus 2 equals to dy over dx. So yeah, this is the required derivative, and if you compare this with the given form, then you have the given thing is dy over dx equals to 2kx minus ky plus 8 over 6y plus kx plus 2, and if you take this one and consider over here, so if you compare our derivative with this one, so you can see 2k equals to 22, minus k is same as minus 11, and we can equate k with 11, so it means from each and every comparison k is 11, so the value of k is 11. So the next part is part B, find the gradient at each of the points on C where x is 2. Okay, so if you put x equals to 2 in our function, we can consider the simplified function from here. For the part b, and if you put x equals to 2 in this function, if you put x equals to 2, because in the part b we have to find the gradient at each point of the curve c when x is 2. So if you replace your x with 2 over here, when x is 2, it will be 11 times 2 square minus 3y square plus 8 times 2 minus 11 times 2y minus 2y equals to 0. So 2 square is 4 and 4 times 11 is 44 minus 3y square plus 8 times 2 is 16 minus 22y minus 2y equals to 0. Okay, so if you simplify this, it will be minus 3y square minus 22y minus 2y is minus 24y, and 16 plus 4 is 60, which is equals to 0. So if you times by minus 1 throughout on both sides, so it will be 3y square if you times by minus 1 throughout, plus 24y minus 60 equals to 0. And we can see 3 is a common divisor of each and every term. We can divide by 3, so if you divide by 3, it will be y square plus 8y and minus 20 equals to 0. Now we can factorize this, and for the factorization we need to consider this term which is minus 20, and the coefficient of y is 8. Now if you add them, we need to find the two pair of numbers. If you add them, it should be 2, and if you times them, it should be minus 20. So if you consider the factors of 20, so 21 times 20, 2 times 10 is 20, so 2 and 10 is the correct pair to get the sum as 8, and if you times them, it should be minus 20. So if we consider minus 2 times 10 is minus 20, and minus 2 plus 10 is positive 8. So these two are the correct numbers with minus 2 and positive 10. So the factors should be y minus 2 and y plus 10 equals to 0. Okay, so if the product of two factors equals to 0, that means y minus 2 equals to 0 or y plus 10 equals to 0. So which means y equals to 2 and y equals to minus 10. So we got the 2 points. When x is 2, y is 2, and when x is 2, y is minus 10. So that means we need to find the gradient at the points at that 2 points. So we already work out our derivative, which is this one. So we can copy this one derivative from here. Okay, so if you copy this from here, okay, so dy over dx equals to this, and we got the 2 points. So we need to work out the derivative at these 2 points. So dy over dx at x is 2, y is 2. So 22 times 2 plus 8 minus 11 times 2, because x and y both are 2, so we need to replace our x and y with 2. So if you work out this, So 22 times 2 is 44, plus 8 minus 22 over 6 times 2 is 12, plus 22 plus 2. So if you add them, it will be 30 over 36, which is 5 over 6. So we have to find the gradient at the other point as well, which is 2 and minus 10. So we need to do the same. We need to replace our x with 2 and y with minus 10 in our derivative. So replace your x with 2 and y with minus 10. So if you work out this, it will be 162 over minus 36, and if you simplify this, it will be minus 9 over 2. Okay, so the next question, number 6, is show by using algebra that the sum of the integers from 100 to 600 inclusive that are not divisible by 3 is this number. Okay, so if you consider the sum of the first 600 terms, the sum series of the first 600 terms, so you can see it is arithmetic series, because the difference between the terms is 1, the common difference is 1, and n should be 600 because these are the 600 terms, and the first term is 1, so a is 1, and the last term is 600, so l is 6. So if the last term is known, we can use this formula as n equals to n over 2 times a plus l for the sum of the arithmetic series, for the sum of the finite terms of the arithmetic series. So since we need the sum of the first 600 terms, so n is 600, so we can replace our n with 600 over 2. First term is a, which is 1, l is 600 again. So if you simplify this, it will be 600, and 600 plus 1 is 601 divided by 2. So if you set this on the calculator, this will give you 603 so the sum will be 180,300. Okay, now if you consider, if we find the sum of the multiples of 3 between 1 to 600 first, so consider the multiples of 3 plus 6 plus 9. The series of the multiples of 3 up to 600 will be 597 plus 600. So again over here, okay, if you take 3 as a factor out, you're left with 1 plus 2 plus 3 plus so on up to 200. Okay, now you can see inside the bracket, it is again an arithmetic series with d1 a1 first term, and n is 200 because these are the 200 terms, and the last term is 200 as well. Okay, now again, if you apply the same formula for the with n 200, so it will be as 200 and n over 2, that means 200 over 2, and times by a plus 1. A is 1, sorry, a plus l, so a is 1, l is 200, so 1 plus 200. So it will be again 200 times 201 divided by 2. So if you work out this on the calculator, it will be we have 3 outside the bracket, so we should times by 3 to get the required sum. Yeah, so if you work out this on the calculator, it will be 60300. Okay, so this is the sum of the first 600 terms of multiples of 3, and this is the total sum of the first 600 terms. So if you take away this sum, which is actually the sum of the multiples of 3 up to 600, and this is the total sum of the terms up to 600. So if you take away this from that, then you will get the sum of the terms which are not multiple of 3, or you can say which are not divisible by 3. So hence the required sum will be 120,000, yeah, 120,000. So as required. Okay, students, that's it for now. Thanks for watching, and we will finish this paper in the next video. Thank you.